Alright, in this particular video we're going to be looking at concentration units yet again, and specifically for those this is POD 11, and in this problem we're going to be working with an aqueous ammonia solution, and what we're going to do is figuring out the molarity of this ammonia given the fact that it has 28.0% by mass. So couple things that we have to understand is that, first of all, molarity is moles of NH3, because that's our solute here, divided by liter of solution. So we have to make sure that our units are correct in order for our final answer to be correct. So it's a lot of just understanding the basic units and how to work through those units. So now there's two pieces of information that they give us. They give you the percent mass, and they also give you the density of the solution. So the density of the solution is 1.165 grams of solution per milliliter of solution. So what we can do is we notice that the molarity is moles of NH3 per liter solution. This is how we get our volume to being from milliliters into liters. So we're going to actually use this to help with us figuring that part out. Now, the other thing is that we have 28% by mass, so that percentage is out of 100, so we can say that we have 28.0 grams of NH3 per 100 grams of solution. And it's just an assumption that you make for the simple fact that the percentage is out of 100. So that, we have to get rid of that percentage of it, so we've got to divide by 100 to do so. So what we need to do is, first of all, we got to get our grams of NH3 into moles of NH3, and we're going to do that by dividing by the molar mass of NH3. Well, that's 14 plus 3, which gives me 17. So we're going to divide this by 17 grams per mole. And so that gives you, that cancels out the grams there. All right. Now I'm going to continue this on into one long calculation. The second thing we do is we look at the fact that we need to get rid of the grams of solution because it's not supposed to show up in molarity. So what we do know is we have the density of the solution, and it's got grams of solution on top, which is where we want it to be. So again, we need it to cancel out, and it's going to be milliliters of solution. So the grams of the solution cancel here as they divide into each other, and there's one part that's left here, and that is the volume being milliliters of solution. So we know that we need to convert from milliliters into liters. So there are 1,000 milliliters per liter. So you're going to multiply by 1,000 so you can cancel your units out correctly. Now it's just a matter of calculating. So we're going to take 28 divided by 100. We're going to hit enter, divide by 17, hit enter, times that by 1.165, and then times that number by 1,000, and what you end up with is 19.2 moles of NH3 per liter of solution. So, or you can just say 19.2 molar NH3. So that's the molarity for this solution of NH3. So what do we get from this? We have to understand that in order for us to figure out the molarity of the solution, we need two things. We need to first the mass percent, and then if you're given mass percent, we need to have the density also provided for us. If you don't have density provided for you and you're given mass percent, you can't do anything. There's no way of going about, because your units won't be able to cancel. So you got to have that density provided to you, or look it up if you're in a place where you can look it up. So now you could go backwards and take the molarity and the density and figure out the mass percent of the solution. It would just be the opposite of what we see here in this problem. So you can go back and forth. But typically when we look at the stock solutions that are in the lab, the bottles are given to us in mass percent, and so what we have to do is we have to look up the density and using the mass percent, and this is how we are able to figure out the molarities of our stock solutions, which then are diluted to give us the molarities that we use in our laboratory experiences. So again, hopefully this will help some of you out in understanding this problem and how to work it. So remember, it's all about units. Thanks for watching.